Hey guys, welcome to Learn Today IGCSE. This video is a tutorial on Chemistry, Paper 4 Theory, Variant 4.2 from February-March 2024 examinations. Question 1. Iron ore contains iron trioxide. A blast furnace is used to extract iron from iron oxide. Equations for some of the reactions in the blast furnace are shown. This is a question from Chapter 10, The Extraction of Iron from Hematite. Hematite is the iron ore, and we are trying to extract or remove iron from this ore. This is usually done in the blast furnace, whereby we will use carbon as a more reactive metal to displace iron. Question E. Equation 1 shows the combustion of carbon in the blast furnace. This is equation 1. Part 1. Name the substance which provides the carbon for this reaction. The extraction of iron happens in a blast furnace, whereby three raw materials are being added into the blast furnace: the iron ore, which is hematite, coke, and limestone. So the substance that provides carbon is named as coke. Part 2. State the purpose of the combustion of carbon in the blast furnace. Combustion is a burning process, and the purpose of this is to provide heat. Next, question B. Iron trioxide in iron ore is converted to iron when it reacts with carbon monoxide in the blast furnace. Part 1. Calculate the percentage by mass of iron in iron trioxide. So we're looking to find how much of iron there is in iron trioxide. Pay attention that there are 2 irons, so we're going to multiply 2 iron over the overall mass. Since we are looking to find the percentage mass, we're going to use the molecular mass of iron, which is 56. So if there is 2, we're going to multiply by 2. 2 iron adding with 3 oxygen. The molecular mass of oxygen is 16. And we're going to times this by 100%, giving us a percentage of 70. Next, part 2. State the name of the iron ore which consists mainly of iron trioxide. As mentioned previously, the iron ore is called as hematite. Next, part 3. Describe how carbon monoxide is formed in the blast furnace. After the coke is burned in oxygen, it will form carbon dioxide, and the carbon dioxide will then be reduced to form carbon monoxide by reacting with carbon. So you can say carbon reduces carbon dioxide to form carbon monoxide. Next, part 4. Write the symbol equation to show the reaction that occurs when iron trioxide is converted to iron in the blast furnace. So the iron oxide will then react with the carbon monoxide formed in stage 2 to form iron and carbon dioxide. Next, part 4. Name the chemical process which happens to the iron when iron oxide is converted to iron in blast furnace. So when iron oxide is converted to iron in the blast furnace, we can see that there is loss of oxygen atoms. So this process is a reduction process. Next, part C. State the type of reaction shown by equation 2. In equation 2, calcium carbonate becomes calcium oxide and carbon dioxide. There are no new products being formed, and whatever products that we can see here comes from calcium carbonate. This process is called as thermal decomposition. Just as an extra information, calcium carbonate is also referred as limestone. It is being added to remove impurities in the blast furnace. Question D, part 1. Explain why the reaction in equation 3 can be described as an acid-base reaction. So equation 3 is a reaction between calcium oxide and silicon dioxide. Calcium oxide is a metal oxide and silicon dioxide is a non-metal oxide. A metal oxide is also considered as a base, and a non-metal oxide has acidic property. So a reaction between base and acid can be referred as a neutralization reaction. Part 2. State the chemical name of SiO2. This is called silicon dioxide. Next, the common name given to CaSiO3 when it is formed in the blast furnace. At the bottom of the blast furnace, the iron will be extracted, and you will also have slag being formed at the bottom of the blast furnace. This slag is the name for this compound. As a summary of this question, you can take a screenshot of the process of extraction for iron in the blast furnace. Make sure you remember all the chemical equation that happens at each stages. Next, question E. Aluminium cannot be extracted from its ore using a blast furnace. Part 1. State why aluminium is not extracted from its ore using a blast furnace. Now in the blast furnace, we are using carbon to displace the iron, as carbon is more reactive than iron. However, aluminium is placed above carbon in the reactivity series. This means that aluminium is more reactive than carbon. Hence, we cannot use this as an extraction method in the blast furnace. And part 2. Name the process used to extract aluminium from its ore. To extract aluminium from its ore, we will use the method of electrolysis. If the question asks you why electrolysis cannot be used to extract iron, you can say that it's because electrolysis is a very expensive process and it requires a very high electricity. Next, part F. Both iron oxide and aluminium oxide contain metal ions with a positive 3 charge. Part 1. Write the electronic configuration of an aluminium ion. If you look into your periodic table, you would see that aluminium has 13 protons. This means that it also has 13 electrons, and the electron configuration would be 2.8.3. However, this here is an ion and it has already donated 3 electrons. So the electron configuration will be 2.8. Part 2. Deduce the number of protons and electrons in iron 3+ ion. So we're going to repeat the same step. An iron atom has 26 protons, which means that it also have 26 electrons. So the number of protons is 26, but as for the number of electrons, we are looking to see at the ion and not the atom. The charge here is positive 3, which means that 3 electrons has been donated. So 26 electron take away 3 electrons, you will get 23 electrons for the ion. Question part 2. The elements in group 7 of the periodic table are also known as the halogens. Halogens can form halide ions. Part A. Identify the halogen with the lowest density at room temperature and pressure. So this is group 7 and these are the elements placed in group 7. The element which is at the most top has the smallest molecular mass, hence it has the lowest density. Next, part B. State the appearance of bromine at room temperature and pressure. You must remember the state and colors of group 7 elements at their room temperature. For bromine, the physical state is liquid and the color is red-brown. So the state would be liquid. Question C. Use the periodic table to give the symbol of the halogen with the highest atomic number and deduce the number of occupied electron shells in an atom of this element. The element with the highest atomic number would be tennessine, and as it is placed at period 7, this means that it has 7 shells occupying electrons. You only have to give the symbol which is Ts, and as it is in period 7, this means that it has 7 shells. Next, question D. Bromine molecules have covalent bonding. Part 1. State what is meant by the term covalent bond. Covalent bond is a strong electrostatic forces of attraction between the nuclei and the shared pair of electrons, and these are formed between two nonmetals. Next, part 2. Name one halide ion which bromine molecules can displace. In group 7, as the elements move down the group, it becomes less reactive. This means that the element on top of the other can displace it to form a different molecule. So bromine will be able to displace iodine. Next, part 3. Explain why bromine can displace the halide ion in D part 2. As it moves down the group, it becomes less reactive. This means that bromine is more reactive than iodine. Part E. Name a halide compound which can be used to detect the presence of water. In your syllabus, you will learn a chemical test for water, which is anhydrous copper sulfate and cobalt chloride. Since they're only looking for a halide compound, the answer will be cobalt chloride. Next, part F. Calcium chloride is an ionic compound. An ionic compound is being formed when a metal element combines with a non-metal element. Complete the dot and cross diagram in figure 2.1 for the ions in calcium chloride. Give the charges on each of the ions. Chlorine atom has a configuration of 287. So to become stable, it's going to need another 1 electron. So we will put -1 here and -1 here. Calcium has an electron configuration of 2882. This means that we need to draw another shell and fill it up with 8 electrons and show that 2 electrons has been donated to chlorine atoms. Next, question G. Aqueous lead ions are added to aqueous chloride ions. A white precipitate of insoluble lead chloride is formed. Part 1. Name a lead compound which can be used in this reaction. So the precipitate being formed here is an insoluble salt, which means that you have to react two soluble salts to get an insoluble salt, lead chloride. That means the soluble salt must be lead something and something chloride. And we're looking to find which lead compound can this be. Now, according to the rule of solubility of salt, all nitrates are soluble. So we can say that this here is lead nitrate. Next, part 2. Write the ionic equation for this reaction and include the state symbols. So they have already given us the oxidation number of lead. That would be Pb2+. Reacting with chloride, since chloride is from group 7, the charge would be -1. And PbCl2 is formed. Ion state symbols are always aqueous, and since this is an insoluble precipitate, the state symbol would be a solid. And the last mark here can be obtained after balancing the equation. So since there's 2 chlorine here, we're going to put 2 here. Part 3, name other insoluble chloride. So all chlorides are soluble but lead, silver and mercury. Since we have already used lead chloride over here, that means the other insoluble chloride would be silver chloride. Question 3. This question is about acid, bases and alkalis. Table 3.1 shows the pH values of some substance. Question A. Define the term base. The same question has been asked from the May-June paper. So the term base means proton acceptor. Next, part B, state what is meant by the term alkali. In the past year question, they have asked you to state the term given to a base which dissolves to form an aqueous solution, which is an alkali. So alkali means that it is a soluble base. As you can see, practicing past papers can be really helpful because there are many repeated questions. Part C. Thymophthalate is an indicator. State the color of thymophthalate in these two compounds. At pH 14, it is an alkali, so thymophthalate would be blue in color, whereas in neutral and acidic, thymophthalate will be colorless. Next, question D, part 1. Use the information in table 3.1 to identify the substance with the highest concentration of H+ ion and explain your answer. So the substance with highest H+ ion would be the most acidic, which is nitric acid. The term acid means proton donor. So the substance would be nitric acid because strong acid loses protons easily. And part 2. Name an indicator which can be used to identify the substance with the highest concentration of H+ ions. So the indicator that will be used here is the universal indicator. Next, question E. Complete the equation to show the dissociation of ethanoic acid in aqueous solution. The dissociation of an acid is a reversible reaction. So we're going to use this symbol. And it will dissociate to form a negatively charged ion and a positively charged ion, like this. And since this question is giving 3 marks, don't forget to include the state symbols. Question F. Write the ionic equation which represents a neutralization reaction between any acid and any alkali. All acids are proton donors, so it will be H+, plus alkali is base, so it has OH ions, giving us water. Next, question G. Dilute nitric acid reacts with aqueous calcium hydroxide as shown. 20 cm cubes of 0.15 mole dm cube calcium hydroxide reacts with 25 cm cube of nitric acid. Calculate the concentration of nitric acid in grams per dm cube and use the following steps. The first step is to calculate the number of moles for calcium hydroxide. The information that we have for calcium hydroxide is that the volume given is 20 cm cube and the concentration is 0.015. To find mole, when you have volume and concentration, you can use the formula of mole equals to volume times concentration. Given that the volume has to be converted into dm cube because the concentration is also in dm cube. To do this, we're going to divide 20 by 1000, giving you 0.0003. Next, part 2. Determine the number of moles of nitric acid which react with calcium hydroxide. They're always going to ask you to find the number of mole for one compound, and then the next question is always followed by number of moles for another compound. And what we're going to do is use the stoichiometry number to find the number of mole. According to the equation, 2 nitric acid reacts with 1 calcium hydroxide. So the stoichiometry number is 2 to 1. We have found out that calcium hydroxide has a mole of 3 times 10 to the power negative 4. The number of mole for nitric acid would be 0.0006 mole. Next, the step 3 is to calculate the concentration of nitric acid in mole dm³. So we're going to use the same formula here, but this time rearrange it to find concentration, which is mole over volume. So the mole has been found in step 2 and we're going to divide it with volume. Remember that volume has to be in dm³. The volume of nitric acid has been given to us, which is 25 centimeter cube. So 25 centimeter cube to dm³ would be by dividing 1000. And the concentration would be 0.024. And the last step, calculate the concentration of nitric acid but in grams dm³. So the same concentration, but we're looking to find it in gram dm³. So we need to do a unit conversion. To do that, we're going to have to multiply the molar mass of nitric acid. Because if we do unit conversion, as you can see, we will be left with grams per dm³. So the molar mass of nitric acid is 63. So 0.024 times with 63, we will get 1.512 grams per dm³. Next, question 4. The equation for the reaction between methanoic acid and ethanol in the presence of a catalyst can be represented as shown. X represents the ester form. This reaction is called esterification. Question A, part 1. In the equation, methanoic acid is represented by this formula. Name this type of formula. This type of formula is referred to as structural formula. And if you were to draw them out, this would be the displayed formula. Next, part 2. Write the empirical formula of methanoic acid. Empirical formula can be defined as the simplest whole number ratio of the different atoms or ions present in a compound. So the empirical formula for methanoic acid, CH2O2. Next, question B. Name and draw the displayed formula of ester X. Ester X was formed from methanoic acid and ethanol. The process of esterification to form an ester is by removing the water molecule, which means that H2O will be removed from this. So leaving us with the ester. And to name this ester, we're going to first take the name from the alcohol. Ethanol would be named as ethyl, and then methanoic acid would become methanoate. So the ester name is ethyl methanoate. Part C. The reaction is reversible and reaches an equilibrium within a closed system. Part 1. State what is meant by the term closed system. So this question here is from Chapter 6 Chemical Reaction. And you will learn in your syllabus that closed system means the compounds or substances in the system cannot escape out. Part 2. State 2 characteristics of an equilibrium. Remember that to help you answer questions like this, you can always refer to your course specification. At equilibrium, the rate of forward reaction is equal to the rate of reverse reaction, and the concentrations of reactants and products are no longer changing. Complete Table 4.1 to show the effect, if any, on the concentration of X at equilibrium for each change of condition in Table 4.1. Okay, there are 3 factors that affects the position of the equilibrium: concentration, temperature, and pressure. The first change of condition here is when the temperature is decreased. To check the effect of temperature, we first must find out if our forward reaction is exothermic or endothermic. Since the value here is negative, this means that the forward reaction is exothermic. If the forward reaction is exothermic, when decreasing the temperature, the reactants will decrease and the product will increase, which is opposite of increasing the temperature. So the effect of X, which is the product, increases. Next, the concentration of methanoic acid is decreased. Methanoic acid here is the reactant. When concentration of reactants is increased, the yield of the product increases. That means if the concentration of reactant is decreased, then the yield of the product will also decrease. Next, concentration of methanoic acid and ethanol are both decreased. Since ethanol is also the reactant, then it will be the same as second condition. And lastly, the catalyst is removed. Catalyst will not have any effect on equilibrium. So the effect is no change. Catalyst will only have effect on the rate of reaction, which is the speed of a reaction. Next, question 5. Butane and butene are colorless gases at room temperature and pressure. Question A. suggests why butene diffuses quicker than butane. Diffusion is a process of molecules moving from a high concentration region to a low concentration region. If diffusion happens quicker, this means that the molecule has to be lighter. The molecular mass of a butene is smaller compared to butane, so this is why it can diffuse quicker. Question B. Identify the products formed when butane undergoes complete combustion. Any compound going through combustion will always form carbon dioxide and water. Combustion is a burning process that requires oxygen. If they were to ask you for the products formed during incomplete combustion, that would be carbon monoxide and water. Next, question C. One molecule of butane reacts with one molecule of chlorine in the presence of ultraviolet light. During the reaction, one hydrogen atom in butane is replaced by one chlorine atom. Name the type of reaction which needs ultraviolet light. This type of reaction is called as photochemical reaction. And this is the same question that came out from October-November 2023. Next, part 2. State the purpose of ultraviolet light during this reaction. The purpose of this light is to provide activation energy. Next, part 3. Name the type of reaction which takes place when one atom of chlorine replaces one atom of hydrogen. Butane is an alkane which cannot go through an addition process because it is saturated. Therefore, it will be replaced instead of added, which is called as a substitution process. Part 4. Determine how many different structural isomers can form during this reaction. It can either form one chlorobutane or two chlorobutane. Even if the chlorine is placed at this carbon, it will still be one chlorobutane. And if the chlorine is placed over here on the second carbon from the right, it is still two chlorobutane. So there are only two different structural isomers that can form. Question D. When but1ene reacts with steam, two possible products form. Identify the type of catalyst which is used in this reaction. This here is a process of manufacturing ethanol by hydration of ethene. So the catalyst used is phosphoric acid. If you are asked for the condition, it will be 300 degrees Celsius at 60 atmospheric pressure. Part 3. Name and draw the displayed formula of the two possible products. When butene reacts with water, it will form butanol. So the product here is butanol. Butanol consists of 4 carbon atoms and 1 alcohol group. The alcohol group here is placed on the first carbon, so it will be named as butan-1-ol. And another way of drawing it is by placing the alcohol on the second carbon, so it will be named as butan-2-ol. Next, question E. But1ene undergoes polymerization. Part 1. State the type of polymerization but1ene undergoes. There are two types of polymerization: addition polymerization and condensation polymerization. Addition polymerization is adding many alkenes to form a polyalkene. So the type of polymerization here would be addition. Part 2. Draw part of the polymer molecule to show 3 repeated units. Now this is what one molecule of butene would look like. But when you are asked to draw polymer, you have to summarize this by only having 2 carbon atoms. What this means is that we're going to only take 2 carbon and then place the hydrogen here, and the rest of it is going to be summarized at the bottom here. So that would be like this. So if we count, there's still a total of 4 C's and 8H. Now we're going to draw 3 repeated units. When alkene goes through addition, we're going to break the double bond and it will become a single bond like this. So this is what 3 repeated units of a butene polymer would look like.